All right, so I was to do this presentation with Jason Green, the EAP architect, but he had a conflict, so I'll do it on my own. This is about EAP7 and Java EE7. So I was just wondering to see, how many of you may use EAP? Just raise hands. And who uses a Wildfly instead? No? OK. All right. OK, so I'm the engineering manager of the EAP team and the Wildfly team as well. And I've been on this project for quite some time, 15 years. As a community contributor, then core developer. I was part of JBoss, the startup, before Red Hat bought JBoss. And I was leading all the JBoss AS releases, the latest 3, 4, and the whole 5 series. And then I became the manager of the team when we did EAP6 and EAP7. Did anyone attend the EAP roadmap presentation at the summit? No? All right, good. So I can talk a little bit about it. We have the two sides. We have the community side, the Wildfly project, which is upstream for EAP, and EAP itself. They're both open source, obviously. Everything that Red Hat does is open source. The major difference, much like Fedora and RHEL, is that Wildfly is the community project. We aim to release fast, make releases around roughly every 6 to 8 months, and focus on innovation, new features, plus bug fixes. But we try to deliver new features or they are baked in the community before we bring them into EAP. And of course, on the EAP side, we have the long-term support. So whenever a new release comes out, we aim to support it for 10 years. We have a very interesting CP, cumulative patch stream. So the latest release receives fixes every 6 weeks or so. We have all the usual stuff, certification, security hardening, and all those goodies. So you can also see the relationship between the two projects. So in blue, we have the Wildfly, what was previously called JBoss AS releases. And the way it works is that at certain points in time, we develop stuff, and then we fork the community project into the product. It undergoes productization, testing, hardening, and so on. And at this point, a major release starts. So we did that with EAP6. And from that point on, we try to maintain compatibility on the EAP stream. And then the community project proceeds to the next release. So in this case, we also had the renaming from JBoss AS to Wildfly. So we had Wildfly 8, 9, 10. And we continued by selectively backporting features back into the product. So, Wildfly 8 fed into EAP6.2 some features, Wildfly 9, and so on. But you can see that it's different because Wildfly was EE7 and EAP6 was EE6. So it's not exactly the same thing. And as things are now, from Wildfly 10, we produced EAP7, which was announced last Monday. And we will continue the development on Wildfly 11, backporting features into the EAP7 stream. And this has worked pretty well, especially after we introduced Wildfly. We managed to increase the pace that we produce releases on the community side. And it has benefited both sides. So the community also receives releases often with the features and fixes, and we are able to maintain the stable EAP stream with more compatibility in mind and so on. It's interesting also to point out the association between the community project on the left. So initially we had JBoss AS 2, 3, 4, and the version of the spec that we implement. And on the right, you see the JBoss EAP releases, the supported product. So on EAP currently, things are fairly straightforward. So, EAP5 implements the E5 spec, EAP6, EE6, EAP7, EE7, and so on. We're probably going to continue with this, with EE8, but we'll see. And on the left, you can see how we increase the pace. So after JBoss 5, we had, for the same EE spec, we have multiple releases. We had 6 and 7, and then for 7, even more. We had 3 community releases implementing EE7. All right, I'm going to say a few things about EAP7, what's new or important. Of course, there's a long list of features. If you go on the website, you can download the release. It's free for development. And you get also some very good release notes of what's new. So I'm just trying to focus on something that I think is interesting or important. So EAP7, it's EE7 certified. We implement both the full profile and the web profile. And the latest version of the CDI and the WebSocket spec. It requires Java 8 minimum. And we have tested all the, the major JDKs, Oracle, IBM, OpenJDK, HP, Sun. No, Sun is gone, so HP, yeah. And we're also testing with JDK 9, and we try to align, the new changes in the module system. One of the biggest changes in EAP7, it's the Undertow project. So Undertow is now the web server inside EAP. And that's a major change compared to the past because, in JBoss AS, for many years, we used Tomcat, a fork of Tomcat, as the web server in JBoss, and that worked pretty well. In the ancient days, we also used Jetty back in JBoss 2, for whoever can remember. Now, the web container, the web server is very important in application server because pretty much many other subsystems build around it. And Tomcat had a few, let's say, limitations for what we want to do. So we see things moving to a massively scalable environment where you may want to do reactive and you may want to do asynchronous stuff. So Tomcat was showing its age because it was designed to be primarily synchronous. Although you had the asynchronous connectors, the core of the server was synchronous. And now, as a result, it wouldn't scale too much, and it wouldn't achieve, like the higher performance we wanted. And the other problem is we always had to integrate at various areas inside Tomcat with JBoss, and we had limitations in terms of what APIs we could use, what extension we would make. So then we started this new project to, see if we can do better. That was about like 2-3 years ago. And Undertow is the result of that, which is a very flexible, small, embeddable web server. You can use it outside JBoss. And some projects actually use Undertow because it's very extensible and small. It's based on let's say, an architecture where you have a sequence of handlers. You can add and remove handlers and modify the behavior of the server in any way possible. And it has a fluent API. It's quite pleasant. And it's quite fast also because you can check out some independent benchmarks that show how fast is Undertow. It's really at the top of the list. Undertow and the latest servlet specification allows us to do things like the port reduction you see there. It's a result of the HTTP upgrade that we use in AS, in the application server. So basically, you can start a connection over HTTP and then upgrade onto a different protocol, like WebSockets, for example. So with this trick, we are able to reduce the open ports of the server to just 2. So we have a port 8080 for applications, for HTTP, EJB, GenDI, native Java interface. And then we have another port for management, where we multiplex HTTP JSON for management, or JMX, or native Java. And we could, in fact, have just one port open, but administrators like to separate management from application functionality. So that's by default now, those 2 open ports. And it also facilitates operating EAP in cloud environments where you have limited resources and you want to have more control over what the server does and what ports it opens. Undertow also has it's now tech preview, so it's not fully supported, but it can act also as a reverse proxy. So it can replace Apache HTTPD if you want. And the benefit there is that you can run Apache Undertow in this reverse proxy mode, and then you just create just another server. So EAP comes either in standalone mode or in domain mode. You can configure the server to be like just one process or one management server controlling many EAP instances. So in this case, you can configure EAP to set up 2 servers, for example, to be load balancers, and another 3 servers to be like a cluster farm beside EAP, and then control everything through a single point, all in Java, no native code. And you can do that, in a small script. Very quickly, you can do that. So that's an interesting, use case you can implement. That's Undertow. Then another big change was Hornet Queue, which was the JMS provider in EAP6. And this is a result of a consolidation of the 2 main messaging services we had in Red Hat. So in Red Hat, we had Hornet Queue, and we had ActiveMQ coming from the Fuse family of products. So those 2 were merged into what we call now ActiveMQ Artemis. So this new project was donated to Apache as this new version of ActiveMQ, and this is what we use. And we hope it may become the main ActiveMQ version utilized by Apache. We also changed the orb. The orb is the Corba implementation in the server. Traditionally, we used JacOrb for many years. But we switched to a fork of OpenJDK, which has some benefits. The main one is that we can pool our resources with Oracle to maintain this, this orb. And then it's easier, of course, to do interoperability testing between OpenJDK and OpenJDK, because it's one thing, right? There's a very big part of the TCK, the test compatibility kit, that checks if you implement the standard correctly, which is related with interop. So one server calling a server from a different vendor, and they have to talk to each other, exchange, make calls, exchange transaction information, security information, and this goes over, IIOP, Corba. So it makes our life easier. Now, because those are changed, if you were before on EAP6, we offer some facility to load on an EAP server the old configuration. So you can load an EAP6 config and call a migration operation of those subsystems, and you get back the equivalent configuration that you need to use in the new, in EAP7. And there is also, another product, Windup, And that comes with some utilities to automate this process, so you can automate part of a migration if you're coming from EAP6. But in general, compatibility is much better than what we had in the past. So if you're moving from 6 to 7, it should be fairly easy. Whereas going from 5 to 7, it's more difficult because it's different architecture. OK, other changes that are interesting. There was some functionality we had in EAP5, but was dropped on the way because we had limited time when we made the EAP6. So this is brought back. And this includes singleton deployment, which is, I have this deployment in a cluster, and I want it to start only on one node. And when this node dies, start it on another node. So it won't start on all nodes in the cluster. Very interesting is also the graceful shutdown functionality. So when you stop the server, there is this mode where you say suspend and you give a timeout. And the server is going to go out and tell the load balancer, I'm shutting down, so don't send new requests. And then it will call the various subsystems and say, I'm shutting down, so do whatever you intend to do. So the various subsystems normally, for example, EJB will stop accepting remotely requests and will just accept local requests. So the in-flight requests will try to finish. The same for servlets. Not everything follows this pattern, so we add more things as we go. So in EAP7.1, we'll have more functionality about that concerning JMS and the transaction manager. So we keep adding facilities. But I think that's quite useful, especially in cloud environments when you have this auto-scaling facility where you start servers, but then you have to, when you don't use the resources, you want to shut down some of them. So that's a good way to stop the server. And it was actually one of the hardest problems when we introduced EAP in OpenShift. We have to think about how to solve this. And this is applied to all systems. I mean, there's a solution, of course, to just kill the process, and then you lose all sessions. They have to fail over to another node. So it's possible, but it might take more time. So I think it's very good to have that. Something else we did was the offline CLI mode, which, if you're familiar with EAP, there's a way to run the server in administration mode, which means don't run services. But still, the server has some open ports and so on. So then you change the configuration and you restart it. Now you can do something similar, but without actually the server doing anything. So it's interesting how we implement it because we have the command line interface, and then what we do is we embed the server into the command line interface. And we start it within the same JVM, make changes per system, and then exit. Which is very interesting if you do things like you do Docker and you want to build your Docker file, so you do your scripting essentially without starting the server. So that's very interesting. Various other changes, like the admin console was greatly improved, the user interface in general, and it can also support very large domains of JBoss. So if you have 100 servers, it was a bit difficult to navigate. Now it's much better. We do things like a hierarchical profile. So when you define a configuration, you don't have to redefine everything from scratch. You can inherit a previous configuration and just define what are your changes. And more, and there's a lot more. So I'm just giving you some highlights here. Any questions so far? Or you can find me later, I'll be around. OK, now a few things about, many things about EE7. The main theme of EE7 was to improve productivity, so reduce boilerplate code, introduce annotations wherever they were missing, make CDI, across all components in the spec, and bring some new web technologies that are, very common. So things like WebSockets, JSON processing. There's this, picture, you've probably seen it, about EE7. In green, you see what changed. So you see the new versions of some of the specs of the EE7 specification, which is quite a lot. And then in blue, you see what's new, the standards that were added. I'm also listing them here. So batch processing is new, concurrency, JSON processing, WebSocket. I'll talk a little bit more about them, so I won't expand here. Various updates to the specifications. EJB had a few. Most important is probably Servlet, that now supports asynchronous I/O and HTTP upgrade. JMS had a big bump in the spec. JMS was notoriously kept for years at the 1.1 version, but now I think it's got a lot better. For the first time, we had annotations. It became much more pleasant to work with. And for the first time, we have actually some specs that are removed. So in EE6, we were introduced to the notion of deprecation. So those APIs were deprecated, which means on the next iteration of the spec, so on EE7, it becomes optional for the vendors, application server implementers to include. So we dropped support for EJB2.1 entity bins. Is anyone using them still? No? You can do much better with JPA. JAX RPC and JAX R is gone. You can do web services with JAX WS. You can do REST now, so no need for that. And there was also a very old API called JSR88 that was about deployment, and it was a very peculiar API that no one ever used. It was very complex and of little use. So, but this one actually, if you're following the developments in Java EE8, is trying to resurface as part of the new management specification called JSR 373. But this time, we try to implement it using REST. Now, batch processing is new in EE7 and EAP7 as well. So that was a spec driven primarily by IBM, who had lots of experience in transaction processing systems and batch processing. So it gives a very interesting new facility in the server. This new API has to do with the notion of a job. So I have a batch job, and the job is based on many steps. Everything you see on this diagram is pretty much configurable. The step in turn is three pieces. So you have some sort of reading facility to get data into memory. You have processing facility, do something with it, and then you write it. And those three stages are part of the single transaction. So in order to make it more efficient, there's the notion of a chunk. So for every step, you can say, I want on this step to process 3 chunks of data, or 3, or 30, or 3,000, whatever. But they're going to be part of the same transaction. And the idea here is that, especially at the reading step, you process record 1, you keep it in memory, record 2, record 3. When I have 3, I write them all together through the writer functionality. And the way to bind all those together, you use this XML-based language, job description language, which is very intuitive. You define a job, consists of steps. Every step, you define your reader, processor, writer. All those are pluggable. You can provide your own implementations, obviously. And then you control it like this. There's a very simple API, job operator. You get access to it through the runtime, provide some properties, and then you start the job. And there's a way to, pause the job, ask about the status, cancel it, whatever. Let me go back a little bit. All the data is persisted in the job repository, which is normally you configure it to be the database of some sort. Yeah, and it's very convenient. So it gives you this ability to do batch processing. And it has a lot of quirks. I mean, I cannot get into much detail, but one example is in the job description language, you can separate your data set into partitions. So you can say, for example, I'll make 2 partitions from 1 to 10 and 10 to 20, or 1 to 1 million. And then when you do that, you configure your reader to also read the data based on those partition borders, limits. So then without changing anything in the code, you change the XML description of the job, and the server can process this data in parallel. So it will make 2 threads, or 10, whatever you specify. It's all configurable. So it's quite nice. I don't hear you. Okay, there's a microphone there if you want to speak in the microphone, or I can try to repeat.
Are the jobs always running within a single server, or can it be distributed across multiple servers?
Okay, are the jobs running within the server, or you have a cluster and so on? This depends on the implementation. And as usual, the spec doesn't specify clustering. And it's part of the implementer to offer something better. In this version, we don't have it. Our own implementation is called JBoss. It's our, we're part of the spec group, so we have our own implementation. And in the next release, we're planning to offer also, clustering facility. We plan to offer, a graphical, some more better graphs on the admin console to show you the batch job and what's the state. So, we're developing it. So not in this first version. Now, batch implicitly give you access to threading in the server. So depending on your job description, the server will make some threads to process your records. And it's a good segue to concurrency, because traditionally, in the application server, you don't have access to threading. And for a very good reason, because the server is supposed to do all the resource management for you. If you start screwing around with threads, anything can happen. So far, the only way to do threading in the server was to use JMS, MDBs. So implicitly, the server will create threads, and you could configure your thread pooling. Or you could use EJB timers, which was part of the spec, to do things kind of asynchronously. But you were not able to use normal threading facilities like those executor, scheduler, like you had when they were introduced in Java 5. In some servers, you could do it at your own risk, the JBoss included, but the server had no idea what you were doing, so it was bad. So now with e-concurrency, we have managed versions of those facilities that are offered in Java EE7, but in a way that integrate nicely with the application server runtime, which is a great thing. So for example, that's how you can do some background execution. You have a managed executor. You inject it with a resource annotation. And then in this example, you can think about you are in an EJB, and you want to do some background job that might take a lot of time. So in this case, we want to do this find needle in a haystack. So basically, what you do is you say to the executor, I submit to you this callable class. That's a 9er class there that calls our method. All right, and I get back a future. So control will go away, and this job will be executed in one of the server threads. And then you can use the future from another thread to check, is this finished or not? I can block waiting for a result, and so on. So it's very easy now to play with threads inside the server. Another more complex example, there's a facility called the context service. So one of the typical problems when you play with threads is the execution context of a thread. So things like its naming context, class loading context, security context, and in also some cases transaction context, is available to the thread. But when you pass a job to another thread, there's no guarantee that those are going to be the same, right? So then what this context service gives you is when you want to pass this execution context to another part of the server that is not aware of that. So for example, let's say you are in a servlet, and you want to execute a part of the code that want to access your context in a MDB, in a message-driven bin elsewhere. So in this example, what we have is, we serve a page, for example, and we want to update a record for this user that has logged in to know what was the last time that he did an operation. And let's say that this might involve a database update, which might be slower, and we don't care to do it on this thread. So what we do here is we create a contextual proxy, which is more or less, it's a dynamic proxy, if you know about that in Java, that wraps this object, the user update object, and we send it off through the messaging service to our MDB, which the code we see below, the onMessage function in the processing MDB. So when the MDB pulls this object from the queue and deserialize it, the deserialization process will recreate the context that the original thread had when it comes to naming, class loading, and security. So then it can find out who was the user that called me and update the record. So it's a bit complicated, but it's doable now. It was very hard to do before. One of the very interesting additions was JMS. So if you have coded JMS before, you remember, you had to look up the connection factory, get the connection, get the producer, create a message, send the message. So you had to, you needed 20 lines of code or more to do a very simple thing. With annotations now, you can do it in 3 lines. So basically, you inject the context and the queue, the queue or topic. And then you can very simply just, create producer, send the message. So it's very, very nice, much more pleasant to work with. In JMS 2, we also have something called a shared subscription. In JMS, you have queues and topics. What you set to a topic is broadcasted to all receivers. So in this example, you have the 2 consumers on the upright that are interested in items of type A. So they've put a selector on the topic, and they say, whatever is a job A, send it to us. So they will all receive the same message. So everything is copied across all consumers. But with a shared subscription, what you do essentially is, in a shared subscription, whatever goes there, it's treated as a queue, more or less. So if you have 10 producers, 10 consumers, in this case, we have 3, and everything that you send there is received only by one. And you can use this in cases where you're doing your own thread management and you want to consume messages and you want to scale up. So you can make more threads, more consumers, and they can all consume through a shared subscription and do their work. Other interesting additions in EE7 was the JAX RS API to allow RESTful calls. So there is this nice template facility where you start constructing your URL essentially, a people service, and you can use also parameters. So in this case, we have an ID parameter which is resolved. It's very simplistic, the example. And you can set on this request, what type of data I'm expecting. I'm expecting, XML in this case, and call this. And you can see in the example that I'm interested in getting back XML that will represent a person object. So that's so the runtime, when it sees that, it will use JAX-B to map XML into a Java object. And at the bottom, you can see how the request is created from this code. So ID will be replaced by 1, and you get the media type. Together with REST, we have also JSON processing, which is a format that's very much common these days. And what we have facilities to manage JSON data in memory and convert back and forth. So you can see how I can build a JSON object in memory with 2 elements, apple equals red, banana equals yellow, and then build it and, of course, write it using a string writer, a stream, or anything of that sort. And you have the opposite, of course, read JSON data back into, read data in JSON format back into memory. So in this format, you have a DOM-like functionality. So your object is all in memory. But there are cases that, if somehow this object is very big, you can process it using a stacks-based API. So in this case, I'm essentially building a pool parser on an input stream. And then I iterate, and I can process and say, oh, this is a new object. That's the name. That's the key. That's the value. And process big data structures or something you don't want to keep in memory. And in general, in the application server, we do a lot of stacks-based parsing for all the XML parsing we do. In EE7, CDI applies to pretty much anything. CDI was introduced in EE6. We were actually the drivers in the specification group, Red Hat. And it became so useful that now we want it everywhere. Now, in contrast with EE6, now CDI is enabled by default. So when you throw a deployment on the server will try to parse, scan all the classes to look for CDI annotations, and set up the runtime. There may be, of course, this has a small performance overhead in case you don't use CDI or you don't use CDI on all your beans. So then, if you want to be more specific, you can still provide the beans XML descriptor and say, oh, scan only those 5 classes, or don't scan anything. In general, it's a good idea to do if you have large deployments. WebSockets is a big part in EE7. WebSockets are used in many modern HTML-based HTML5 applications where you want essentially client and server to push data to each other, asynchronously. So WebSocket normally operates using the original HTTP request that we upgrade to WebSockets. It uses a framing protocol internally, so you can push arbitrarily large messages that will be framed. And you can push messages, text messages, or binary. It's very easy. It's a very easy protocol. And you can see how you would use that from JavaScript. So in this example, I just create a WebSocket. You can see the WS : / the beginning to tell that it's a WebSocket. And you define a method to receive callbacks. So the onMessage method will be called whenever data is received in the web browser. And you can just send the message, example socket send hi there. It's very easy. And that's how you could implement it on the server side. So in this case, I defined an endpoint at the address WebSocket, and it also provides a parameter, so we can read separately this part of the URL. And now how you process things on the WebSocket, it can be synchronous or asynchronous. In this example, whenever the client gets connected, we'll get back a callback on open method. And what we do there, you can see, I get back the session, and asynchronously, I will send back a reply. Again, you can do it synchronously or asynchronously. And then whenever I receive a message, I can, in this example, we just echo it back to the server, and you can see it reads back the name parameter. So it makes it very easy to write, basic WebSocket examples. Similarly, you can handle binary messages. So you see there's a binary message method. In this case, you don't receive a string, you receive a byte array. And you're also informed, when the connection is closed, and you can do something with it. Like here, we just log it on close. Similarly, now in this example, the server acts as a server essentially to the web browser, but it can also call out to other services. So in this example, we are in a servlet, and we get access to the server container, and we want to connect to another server. So because exactly, WebSockets is asynchronous, you can send and receive at the same time. What we do here is we provide the callback. The class annotated client endpoint is our callback class that will be called whenever there is incoming data in the WebSocket. All right, so we provide our callback, and then we send the message in this example. And here we send it asynchronously. Again, you have the option of synchronous or asynchronous. And here you can see this callback class. So I'm the client, I send it something, and then whenever there's traffic, inbound traffic on the WebSocket, I receive the usual callback. So I get on open, on message, and I can do something. And in this case, I synchronously reply. So pretty simple and pretty powerful. And I'm going to say a few things about the latest servlet spec. The part that's interesting to us is HTTP upgrade was very interesting addition, and then the asynchronous processing API. So far, servlets were synchronous. Now we have this new ability to act asynchronously. And Just want to say a few things about blocking versus not blocking. The synchronous API has the advantage that it's very simple. It's much easier to write code. Asynchronously, it's much more difficult to write code. Now, the synchronous mode assumes that I'm reading something and it's available, and then on the opposite, I write something. I assume that the receiving side is able to receive it. So that makes my life easier. But of course, it doesn't scale so well. So Tomcat can handle 200 concurrent connections nicely, but if you go over that number, it starts struggling. So if you want to deal with 2,000 connections or 200,000 connections, then you need a different mode. And in the asynchronous mode, the way you operate is that basically, I just read any chunk of data that is buffered close to me, and then I write, again, as much data I can push in the socket without blocking. So I have to deal with small pieces of information continuously and run in a loop where I read, I write. If you've done Unix, socket programming, you probably know how this works better. So in this example, we see how I would do asynchronous I/O in a servlet. And the big difference is that, OK, I have the doGet method. And at the first line where you see, asynchronous context equals request start async, it's the exact point where I tell the server that, OK, I want to act asynchronously in this servlet method. This example assumes that the servlet needs to serve an amount of strings. In the example, we just have 3 strings, but let's imagine that we had like 1,000,000 strings, and we want to push those to the server. Obviously, it would be impossible to do it in a blocking fashion and without performance issues. So here, what we want to do is we want to process that asynchronously. So essentially, let the server know us, can I push data? Yes, all right, I push some data. And then, can I push data? And then if I cannot push, I do nothing, So basically, what this code does is it just provides a callback, this inner class called writeListener. And then the code falls outside. So basically, I set the mode into asynchronous mode, and I exit. But I've given the server a callback, the callback with this method in blue, onWritePossible. So the server, when I can write to the socket, it will call me back and will say, oh, now you can write. So then you can check, my stream is ready for writing. Yes, all right, I write something. And I loop back. As soon as the string is not ready for write, I do nothing. And the server will call me back again when it's ready. And when I'm done, I have to say to the server, I'm done. So I will say, context complete, and this is over. And this is how you do non-blocking I/O in general. Now, the facilities that the servlet spec provides about blocking I/O are, relatively simple. It's what we saw more or less. In JBoss, with Undertow, we have also our, extra, APIs, which are not standard, of course, and they're related to how Undertow gets extended. So we have something called the handler, and the handler is the equivalent of what you had in Tomcat called the valve. The server behavior is constructed by many handlers that operate in a row. So in this example, you see a very simple handler that will allow you to make a server that will just return hello world on whatever you ask him. It doesn't even look at the input request. It just outputs hello world. That's it. Now, Undertow operates in a way where it has two thread pools. It has a small I/O pool that is used to perform all the reading and writing of data in a non-blocking fashion from sockets. And this is normally sized up to your processor ability. So if your processor has, 4 cores, whatever, 8 hyperthreads, it will make a thread pool of, I think, either 8 or 16. And this is a limited thread pool. At the same time, for things that will block, it has a much larger thread pool. I think it's up to 100 or something. And then you have to, in those handlers, you need to be very careful on which thread pool you operate. So in this example, the user wants to write a handler that will act in a blocking fashion. So when the request starts, and I get the callback at handler request, the very first thing you have to do is to check, am I operating in the I/O pool or the big thread pool? So there's this call exchange is in I/O thread. And if I'm in the I/O thread and I want to do blocking, then I'm at the wrong place. So immediately what it does is it dispatches this request and returns. So basically that means, put me on the other, or the blocking thread pool. And then you will receive again the callback, but now you will be on the right thread pool to do the blocking stuff. So that's a small detail. There's some stuff you can read online about, HTTP as implemented in Undertow, if you can do advanced scenarios. And I think with that, I'm done. You can try EAP7 for free, or you can try Wildfly as well, Wildfly 10. There's a lot of material that was released together with the release. And that's it. I think we have a few more minutes if you want to make any questions. Nothing?
Thank you.
Thanks.